our next talk is from Paolo Ricciuti. Paolo, you're joining us again. This is, I think you're one of very few people that are second timers on the content, along with David and the MCP UI guys. So congratulations. You obviously were so good the last time you were here. You know, we couldn't help but sort of say, come back, Paolo, quickly, bring your fantastic presentation styles. And this is going to be a fun one because you care deeply about Svelte. This is obviously your baby and something you have worked on for a long time. And you're going to share with us today the Svelte MCP and what you did to kind of build it and the journey you've been on with it. So I want to get your slides up and get out of the way because I'm super excited to hear this talk.
Yep. All right, so this is my talk, which is also called How I Taught LLMs How to Svelte. And before we begin, a small presentation is due, and I brought my personal assistant here, so I can say, can you help me present myself? And let's see. I absolutely can help you present yourself. You're Paolo Ricciuti, that's correct. Where do I come from? You come from Campobasso, Italy. That is correct. Where do people can find me online? People can find you on Blue Sky as paolo.ricciuti.me. That is absolutely correct. What about GitHub, though? You're absolutely right. People can also find you on GitHub as Paolo Ricciuti. What am I mostly known for? You're known for being a Svelte ambassador and a Svelte maintainer. That is absolutely correct. Where do I work? You work as a senior software engineer at Main Matter, which is super cool because I get to work with Svelte, but also to teach Svelte, both at conference and meetups, and in my day-to-day job. Because we are a consultancy that basically specializes in Svelte, Rust, and a bunch of stuff. And we do what's called the team augmentation, which means that we join your team, we help you hire, we help you with best practice, but work for Svelte, but also with AI. We recently did a workshop on MCP, and in general, we teach you best practice on how to apply AI responsibly in your company. Okay, thanks. And let's move on to the presentation. And glad to help. Let me remove this conversation. Now it's over. RMRF. What? Okay, it's broken. It's fine. So as I mentioned, I am a Svelte maintainer, and so I love Svelte. For those that doesn't know about Svelte, this is the homepage of our website. And if we zoom in, we can see that Svelte is a UI framework that uses a compiler to let you write breathtakingly concise components that do minimal work in the browser, uses languages that you already know, HTML, CSS, and JavaScript. And it's a love letter to development. And you can see why. This is a Svelte 5 component, and it's basically comprised of three main blocks. It's the script tag, where you can declare variables with the $state to make that stateful. And then whatever you declare inside the script tag, you find it available in the template part, where you actually write your HTML. And you can see that you don't have to access a variable with .value. You don't have to set it with setCount. It's just a normal JavaScript variable. Style is also an important part of the component because you can see that I don't need to use classes. I can just do button because every style tag is it's scoped to the component that is written on. So it's a pretty sweet language. It's the most loved framework. But if you notice, I had to say this is a Svelte 5 component. And this is also a Svelte 5 component. But the reason why I had to specify Svelte 5 is because there was a big jump between Svelte 4 and Svelte 5 in terms of syntax. So as you can see here, we have initial and save from props. This is how you get a prop in Svelte 5. We have stateful variable count. We have a derived of count times 2, which is derived reactive variable. Effect is to use side effect, like writing to local storage. Inspect is to log something. And then we have this on click, which in Svelte 4 looked like this. So as you can see, the syntax is pretty different. You had export let instead of $props, normal variable, and this colon syntax. $$ syntax for both for logging, for derived state, and for side effect, and also on colon-click instead of on-click. So it was a pretty big change. And who absolutely love big changes? Our future overlords, obviously. So obviously AI is not really like a heaven match with big syntax changes. Especially we released Svelte 5 basically at around the time where LLM started to gain popularity. And so this was probably the most the usual AI experience for people that wanted to write Svelte 5 code. And there is a reason for that. So if we have this small, simple graph, this is probably the amount of Svelte 5 code that is out in the wild now, today. And this is the amount of Svelte 5 code that looks like Svelte 4 code, because Svelte 5 is completely back compatible. If to this we add the amount of actual Svelte 4 code out in the wild, because obviously not a lot of people can migrate their app, and maybe there's some old project that will never get updated. And to this, if we add the fact that Svelte 3 had basically the same syntax, you can see how LLMs can get very confused. The amount of Svelte 4-like code out in the wild is very much overweighting on the other side. And so this is the kind of code that LLMs wrote. They imported $state and $effect, which you don't have to. They used on::click instead of on-click. They passed the function to $derived instead of just passing an expression. Or for example, they used the old way of doing reactivity with stores. So even if it was a stateful variable, they still used update and $count. They did this thing, I don't know, this happened to me, but I don't know where they come from, the $. And they also did something like this, where technically this is correct Svelte 5 code, but it's not really good Svelte 5 code, because it's assigning state inside an effect where you should just use a derived. Although I have to say that I am kind of judging you, because I've seen this code in the wild, even written by human engineers. Now, the problem is that LLMs are kind of frozen in time. The moment you stop training them, that's it. You can't add more information to them. Well, more or less. You can technically add context to them. And I mean, this is not the kind of context I was talking about. This is how to add context to a Svelte component. But from context, what I mean is that you can technically instruct the LLM in your prompt on how to write Svelte 5 code. Now, I wrote a script to write this thing inside Claude, and I'm already bored even just to watch it write. You can't really do this every time you have to write a new component. And so almost 1 year ago, during Advent of Svelte, we released llms.txt. I think we were one of the first frameworks to do it. But basically, if you go to the Svelte docs, you can just post-append llms.txt, and you get something like this, which is basically a markdown file that instructs the LLM on how to use that specific part of the documentation without all the fluff of the HTML. And so LLMs could scout the word and read that file to learn how to use it. However, this was really not enough. And so we received a lot of complaints because people actually wanted to use Svelte 5 or wanted to pick Svelte over React, but just couldn't, because if you can't write good Svelte 5 code with LLMs, it will be a liability for you. Now, modern LLMs actually kind of solved already the problem. We saw since Claude 3.5, almost the new LLMs kind of solved this problem, but still a lot of people were complaining. And so, in the monthly maintainer meeting, we decided we need to do something about this. What we can do? Well, we actually launched a specific task force to try to solve the AI problem with Svelte. And obviously, there were a lot of ideas floating around, but we quickly realized that a lot of those ideas involved an MCP server. Now, I don't have to tell you what MCP stands for. It's Model Context Protocol. And in short, it's a way for MCP client like Claude Code or Claude, Codex CLI, Gemini, Copilot to talk to MCP server like Figma, Linear, GitHub, Playwright, and now even Svelte. And so like this MCP server can either act on the real world, like change, call an API, do stuff, or they can answer back, adding more context to the LLM. And this is basically what allow me to do stuff like this. So I have this open code where I asked for the slides that you are actually seeing. And these slides are actually an MCP server. So I can do, can you go to the next slide? And if everything works, yeah, it worked. Now, obviously, I will not do this a lot because that would be the most expensive auto-clicker ever. But at the time, I was a bit skeptical about it. Like, how can a framework have an MCP? Is it just to inject doc? And to be fair, like the initial implementation was exactly that. Scott Spence, which is a fellow Svelte ambassador, did exactly that, and it basically created an MCP server that served the documentation. And this is basically what most frameworks do. Like they have an MCP server that serves the documentation. Maybe they can serve like your route structure and stuff like that, but that was it. After this original attempt, Stanislav also did something similar, a bit more structured, a bit more involved in the sense that he's also added some use cases and some scenario that helped the LLM actually like build like a better understanding of Svelte 5. And this was also pretty successful. And so we actually started from his implementation, like we knew that we wanted the docs at least. But then we actually realized that most of the suggestion that we had in our task force was around the idea of having the MCP server actually read the code that the LLM generates. And we can actually do that because like Svelte is a compiler. We are pretty good at navigating the user code from a string. And so we said, maybe it could work. And so what we did is basically implement some sort of mini agentic workflow. So this is the normal agentic workflow, right? Like the user writes a prompt, he gives it to Claude, Claude generates some code and then checks the code and then generates some code and then checks again and then generates again and then checks again and then goes back to the user. With the MCP server, we basically wanted to do something a bit the same, but with an extra step. So now you ask Claude, it generates the code, it checks the code with the Svelte MCP server, and then gets back an answer and generates a new code, and then checks with the Svelte MCP server, and then once again. Now, let's actually see the code for this magic here. Now, I'll build this MCP server with TMCP, which is a library that I wrote. So that's why the code will look a bit different, but don't worry, like you will get it. It's very close to the official SDK. And so this is the tool that we actually think is the main protagonist of the MCP server, of the Svelte MCP server. And it's called the Svelte autofixer. The description is very simple. Like given a Svelte component or module, returns a list of suggestions to fix any issue it has. And this tool must be used whenever the user is asking to write the Svelte component before sending the code back to the user. The schema, the input schema is actually pretty simple. You just get the code, the desired Svelte version, which because we also want you to be able to use it with Svelte 4, and the file name, just to give better output. The output schema is also very interesting because it's an object with a list of issues, a list of suggestions, and I think this is the real key. Because before I added this output schema, the LLM was calling the autofixer, getting back the suggestions, fix the suggestions, and then, okay, I guess it's fine, and just return that to the user, ignoring the fact that added some new issue while fixing the code. And with this, we basically unlock the continuous loop that I was talking about. There are some annotations, but this is the actual code. So first, I actually checked that the version is 4 or 5. I had initially this inside the tool, but Cursor was actually going mad about it. Like as soon as it tried to pass this, it tried to parse it, and it was going into loop. So I had to change it, and I had it inside the tool. But then we generate this content stuff, and then what we do is that we compile the code that the LLMs gives us, and we return every issue and warning that the compiler already returns. Then we run the autofixer on this code, and the autofixer are just basically us doing static analysis on known pattern that the LLMs get wrong, so that we can correct them. And then we literally run ESLint at runtime to use like the Svelte ESLint plugin, so that we can get even more warnings and issue with that. Obviously, if there is an error, we push the issue. But this, I think it's a very important point. If there is a JavaScript parse error, it's something that we cannot parse the component and we cannot run everything. But something that we noticed is that sometimes the LLM was writing code like this. Like instead of creating an actual variable, was prepending $state instead of let or const or var. And so we can't actually explore the code if it's not compilable. But what we did was actually, okay, if there is a JavaScript error, I will return this suggestion. And I think this is very important, because the code is not actually fixing the code. It's just telling the LLM, please check if that's the case. Like, it could be a different JavaScript error, but we don't care. Like, we return the suggestion asking the LLM to please check if they're doing stuff like this. And after we do that, we basically say that if there is any issue or any suggestions, we require another tool call after you fix that. And we return everything with a structured content. And the solution looks something like this. So in this case, like this is a small playground where we are the LLM. And we can see that if I do stuff like this, and I do import from Svelte runes, for example, and I do $state and like this, for example, you can see this is actually contacting the MCP server, and it's saying that the $sign prefix is resolved. So sometimes the LLM was just doing, okay, I will remove the $sign. And in this case, you get a lot of issues because you're saying like you are using the state rune, but there is a local binding called state. $sign prefix will create a store subscription. You are importing state from Svelte runes. This is not necessary. All runes are globally available. Please remove this, import, and use $sign state directly. So like this kind of suggestions is basically giving more context to the LLM instead of just fixing the code, because there's just so much that we can do with static analysis. But LLMs, given context, are really good at fixing the code. And so instead of fixing the code for them, we are just saying, hey, please do this. And so this also helps us into let the LLM write good Svelte 5 code. So we can say let double is equal $state count time 2, for example, and then we do $sign effect like this, and we do double is equal to count time 2. Now, this is technically correct Svelte 5 code, but the problem is that a stateful variable double is assigned inside an effect, which is generally considered a malpractice. Consider use derived if possible. So this kind of stuff basically means that we can guide the LLM not only to write correct Svelte code, but good Svelte code. Now, obviously, it's not a silver bullet. So like if you have like less smart model, for example, I tried to run this with Qwen 3 and it got stuck for like 30 minutes. It was just calling the autofixer. The autofixer was saying, you should fix this. And he was just ignoring the autofixer and sending back the code, basically how it was before. So like, it's not a silver bullet. Also this, I found it very funny because this was a chat that I had with GPT OSS 20 billion. I really wanted a 20 billion parameter to work. And actually, he wrote some decent Svelte 5 code, but when I had a slightly different problem, you can see that, okay, I'm stuck. Let's try another way. Okay, I'm stuck. And in the end, it's just saying, okay, I'm stuck. I'm sorry, but I'm unable to resolve the autofixer suggestion. So the model needs to be smart. But when the model actually gets it, then that's really fine. For example, I've used this Mistral with Mistral 2, I think, or Mistral 3, I can't remember. And you can see that I asked him to create a Minesweeper component, and he actually wrote like some code that was wrong Svelte 5 code. But once the scroll finish, sorry, it will take a while. You can see that now it called the autofixer 5 times in a row, and in the end, it actually got some pretty good Svelte 5 code. So this is absolutely exciting for me because I can actually write pretty good Svelte 5 code. Obviously, we also have something like resources. Like we have a pretty mature MCP server. So if you know that you need state, you can just use the state resource right in your MCP server. And this will basically give you the same llms.txt file that you can provide to the LLM if you know that you will need some of this documentation. We also have prompts, obviously. So like if you want, you can use this Svelte task prompt, and this will basically instruct the LLM on how to properly use the MCP server and also give the available docs directly in the prompt. Another very interesting tool that we have is this. Now, you may see these and things like this is just like gibberish. In reality, this is a Svelte playground. So this is a Minesweeper component that was built by an LLM, and you can, like, once you are building on something with the LLM, at the end, the LLM will ask you, like, do you want me to generate a Svelte playground? And it will give you this a bit admittedly huge link. And that's why we also introduced MCP UI. So like if your client supports MCP UI, you will get a Svelte editor with the result directly in your chat, which is super cool. Now to try this, you can just use https://mcp.svelte.dev/mcp for the remote version, or mpx/y-y at svelte.js/mcp to actually run it locally. We are also on the registry, and please, if you have any other issue with LLMs, open an issue because we can probably fix it quite easily. And I guess the only thing left, I don't know if it came true. It's a thanks for watching, by the way.
Oh, Paolo, that was fantastic. And really amazing journey you guys have been on. I mean, this has been a year of sort of learning how to get LLMs to work well with Svelte and building ever more powerful MCPs and ever more advanced tools to help. Let me ask you, I mean, do you feel like you're getting to the end state? Like, is this kind of, you know, you're like, this is about as good as I think we're going to get it. Like, we've kind of figured out how to do it? Or do you feel like this is something that's going to continue to improve?
I mean, we definitely want to continue improving. Obviously, like, I'm following the whole MCP spectrum pretty closely because, like, also being the author of the MCP, like, I'm really deep into the protocol. So, like, whenever there's some new toy that we can play with, we try to implement it. For example, we also definitely want to, like, convert the MCP server to a skill so that you can actually use like a cloud skill instead of the MCP if you want. So we are exploring, and obviously we are also right now we are in the process of, because one of the problems is that the documentation can be pretty verbose, and this means that, like, it will bloat your context a bit. So something that we actually did was we summarized the documentation with an LLM. Now, to actually make sure that this doesn't really affect at all, we needed a way to test the fact that it was not affecting us at all. And so we are actually building the second version of the Svelte bench, because Stanislav also built Svelte bench, which basically, like, every new model, he runs like 100 tests on a new model by itself without an MCP server to see how well it generates Svelte 5 code out of the box. But now we're actually building the version 2 of the benchmark, where we can actually decide like to run with the MCP server or not, in an agentic flow or not, we give access to test or not. And so like we are building this benchmark so that we can actually measure how much the MCP server can have an impact on writing Svelte 5 code.
Is there who's the leader in the clubhouse right now? Like which LLM is the best for writing Svelte 5 code?
Just recently, Opus 4.5 was the first model to actually get 100% score on the original bench. Mm-hmm. In general, I would say like Sonnet was, like Claude in general was the first to be consistently good as Svelte 5 out of the box. Mm-hmm. Gemini 3 obviously also. OpenAI is always lagging a bit behind. I think that I don't know if they are doing something with their system prompt, like steering the model to actually write like React instead of Svelte. But I've also asked like Grok, Gemini, Claude, and ChatGPT, what is your favorite framework? And all of them say it's Svelte. So,
oh really?
Yeah.
That's
if
so
you want to make your LLM happy, write Svelte.
Oh yeah, maybe because it makes sense because like it's lying to you. It's the same way that developers lie to you. But like they're like, oh yeah, Rust is my favorite language, but they don't program in it, right? Yeah. Because it's just echoing the sentiment of like, oh yeah, Svelte is one of the most highly liked languages or whatever.
Yeah, I think that's exactly it. Like the point is like a lot of people really love writing Svelte. Yeah. Like it's the most loved framework of all. Like it's not the most used, but a lot of people want to write it, and the LLM is just picking up the sentiment.
Our product is actually built on Svelte, but so I really liked the approaches that you took because it's kind of these ideas of like basically like it's like you're writing a tool that's kind of like assisting the LLM or kind of almost kind of conversing with the LLM of like you didn't have to get the answer right, but you could make suggestions of just like it seems like you're just giving it more context or more information and helping it. You don't necessarily have to write a tool that is going to like 100% get it right. And it's kind of like this idea of like, LLMs, like in a one-shot approach, LLMs are only so good. They can only be so good. And they keep getting better and better, which is amazing. Like I'm sure that, that benchmark that you're testing is pretty much doing like one-shot tests. But if you just have this thing where it's like, well, you give it feedback and you allow it to correct itself, and then then it kind of eventually gets to the right point. And I really kind of like that model of just more agentic. And
I think like I might be biased because like we had this idea, but I think this is the right way of build every MCP server. Like obviously like MCP servers are a way also for the LLM to like modify the external world, but if you have to give something back to the LLM, you should lean hard on the fact that the LLMs are pretty smart if you know what to tell them.
Yeah, and this is also another like pet peeve of mine because I can't stand a lot of these like deterministic workflow systems that people call agents because they're like, oh, on this node you're going to call this MCP server and then you're going to get that out, and like it doesn't allow for the agentic part where it's like no. Because there's one of the things we noticed very early, because before MCP we built this system called GPT script, though it's whatever that it kind of mimics a lot of what MCP does. As we noticed that it was like, oh well, if the LLM screws up or like if it gives the wrong arguments or whatever, just tell it that it messed up and then it fixes itself. So like it doesn't matter so much. It's like if you just allow it to fix itself. So it's like, kind of accepting the fact that, LLMs aren't perfect, just the same way as humans aren't perfect, but we eventually get to the right place.
I think like this is probably like the engineer part of our brain that is craving for that deterministic way of doing stuff. And I think like a good like mental model is actually doing the opposite. Like yes, like you should use the deterministic part, but you should also pay attention to the fact that the undeterministic part is very smart nowadays. And so like you can guide it to actually do what you want.
Yeah, I mean, I think as engineers, we love. I mean, that's why we got into programming, and so much of us is like kind of like that very specific outcome. But programming with AI, I think is really it's almost more like dealing with people. It's how do you accomplish things with people. So if you think like, well, what would I do with how would I interact with the person, or how would I structure a team, or whatever? It usually ends up being the better solutions for AI.
Let me ask you, Paolo, when you think about like a new, you do a lot of training, right? So you walk into a new team adopting Svelte in a company, or a new Svelte developer that's coming out of university or something, and you're saying like, okay, let me help you get your MCP stack defined. Like, because at this point, I kind of feel like if you're giving this to a developer, like, yeah, you can give them this piece, but do you need Chrome tools? Like, what is this? Like, I almost would love someone to write a blog about this, but like, what is the stack of tools you would recommend as MCPs that a new Svelte developer start with? Okay, you've got your client. What do you install? Like, what are you recommending? What are you using? What's in your workbench?
I actually don't use like a lot of MCP servers. I think like this is pretty usual. Like whenever you start understanding MCP server, you start removing a bunch of MCP server instead of adding new ones, because you know that like it's only the real important ones that matters. Obviously, like if you are dealing with Svelte, definitely use the Svelte MCP server. I think also like the usual suspect, like the Chrome DevTools and the Playwright ones are pretty good, because the moment you do front end, you probably want the LLM to have access to what is actually on the page.
Yeah.
And something that I've been like, it literally like I started using it a lot is actually the front end designer skill that Anthropic released, because it's night and day. Like usually, like I am a pretty bad designer, like in general. So like even when like I let Claude design something for me, usually it's better than me. But with the front-end design skill, it really step up a notch. Like obviously, that is really only like if you have a designer at your company, you don't need that, because the designer will tell you how to do your page. But for personal projects and stuff like that, it's very like we are running the advent of Svelte even this year. Last year we did basically like a new release every day with a new feature. Like it was super fun, but also exhausting, because we had to prepare months in advance, like to get everything. Okay, we need the 24 features to release and stuff like that. And it was very fun, also for the people receiving them, obviously. But instead, this year we are doing like education. So like every day we release a new like. Every day we release a new video, an instructional video about Svelte, everything that happened in the last year. And it's helping me a lot, because like, obviously, if you are building a demo, like you don't care too much about the code and the design being in line with the rest of your product and stuff like that. But like being able to spin up like good looking demos in a snap, it's very nice.
Very cool.
So
go ahead, Darren. One more.
As much as we talk about MCP and how great MCP is, I'll be perfectly honest. In development, I don't use a single MCP server. Never.
Cool.
Nope, not a single one. Like it's very, very hard for me to find, specifically for development, because like Claude Code and those things are so good that like it's like the generic set of things that it already has available to it are pretty much good enough, which is because it has access to the CLI. Yeah. So I don't use a single MCP server.
I do use some of them, but I agree. Like for development, I use very few of them. Another one that I recently actually I also worked on on a similar one, which is for the AITNE initiative. AITNE stands for Ecosystem Performance, and it's basically an initiative to actually debloat the JavaScript word, because there are a lot of packages that basically just install, like there are a lot of people that just install the usual suspect, like child. Yeah. Pretty good, but it's a bit bloated, and you can mostly do that with Node.js nowadays. Yeah. And so like this ecosystem performance stuff is basically collecting a bunch of like alternatives to packages that are a bit over like bloated or old one. And we built an MCP server for that, so that when the LLM is installing a new package, it runs the install script through the MCP server and say, hey, don't use that package, use this other one.
Yeah. Yeah. Well, so, but when so like kind of like the counter, because the thing is like, so I developed Svelte and Svelte 5 and everything, but and I've done, well, again, I'm using Sonnet or Opus or whatever, because it's Claude, so I'm using but like one of the things though is like the best thing I find for a lot of these things is just linters and things like that, like the tools that are already doing the validation, because I don't necessarily, because like a lot of times, I mean, I kind of like my flow with writing code and stuff is like I just kind of get AI to spit out whatever, because I'm just trying to test things and mostly get it. And then once I'm happy with the approach, then I go and start fine tuning the code and things. And so then I'll be like, okay, we'll run the linter and stuff and fix any issues. And so I kind of go through like I start with a little bit of slop and then I refine it. And so it's like it's not a one-shot thing. And since I'm already semi-experienced on Svelte 5, I immediately know, hey, that was
it's a total, like when I'm using it, it's so different, because I really rely on Playwright and things that can kind of evaluate why is this not looking the way I want it to, because I don't write code, right? I'm not a developer. Yeah. So for me, I actually don't use any of the MCPs that are more sort of coding side MCPs. I use the test type MCPs. Like, why is this not look the way I want it to look? Why is the front, especially for front end stuff, because it's the behavior's not it's not working. Figure out why it's not working and help me go back. But with those things, someone not a developer can actually, treat it more like a contractor. You're really treating it like a development contractor that you've hired, and you're sort of, no, these are my 12 bugs or 15 bugs. Or 20 bugs. Keep improving.
And I think that's kind of like the nature of, like, because when you look at MCP, it's like, it's kind of something behind the scenes. It's a connector, it's a plugin or whatever, where it's like, once you build an AI product or whatever, so Claude Code is for a very specific use case of developing for already experienced, not already, like whatever, a developer kind of knows what they're doing, it's on the command line and everything. So it's like, once you develop the product, like more MCP plugins is often like, I don't think that's like a very common use case. It's more like as you're building the product and the experience and stuff, at that time you might pull in different MCP servers to build that experience. But once you get to kind of like the end user, it's like it's very, it's kind of it's a little, because that's what we're seeing even with like, let's say like MCP apps. MCP apps is like a like what we're doing with ChatGPT apps and things like that. It's really a subset of MCP that's for a very specific use case. And then like now that makes sense for why the developer might, or the user might bring it into the application. So it's like, the MCP is still kind of a, very useful more on kind of like the back end constructing the application than it is, I think, on like users just randomly picking one and throwing it in there, just because it's, like what is an MCP? Yeah, it's like,
all right, we promised to not go over 20 minutes. And we're so far over. This is definitely our most over episode ever. We're like an hour and 20 minutes into this conversation. Paolo, that's a great sign that you're a fun guest to have on. And honestly, Adam was great too. It was really nice to have you share. This was good. A good episode. Thank you everyone who joined us today and watched. As always, these will be up on YouTube if you want to share them with your friends or go rewatch bits you had to run off for. And we will be back next week before the holiday break for one more episode of The Context. And everyone, thank you again. Have a wonderful day.
Thank you for having me.
Absolutely.